Respected chairperson, the eminent speakers on the dais, and all the industry experts of the dais. Good afternoon. For next 15 minutes, I'll be talking about the CO2 EUR effort of Oil India Limited and its initiation. So, as a customary slide, this is the enhanced oil recovery. So, as a layman, what we can expect is in enhanced oil recovery, we inject something into the reservoir to break the bondage between oil and water or oil and rock, so that the extra oil flows into the wellbore. So there are various methods. In primary recovery, we can have a recovery factor of at least 20%, and after secondary, we can at best go up to 40. But what is painful is 60% is left behind. So that is why tertiary or EUR methods are there to improve the recovery. So why? Why EUR? It has already been discussed. Even our chairperson has already told that the supply-demand gap, that is what is forcing us to go for EUR. And apart from this, we can see that in the graph, the last discoveries, the Burgan field, the Ghawar, or Jakum, all these fields were discovered way back. And in more recent times, last discoveries are diminishing. That is why to support consumption, we have to think of an alternative way. So this is the mechanism of CO2 EUR, how it works. So CO2 can be injected into the reservoir, and both immiscible and miscible flooding can happen. Somebody was asking during the first presentation that how CO2 will work. So generally, it is advisable to inject CO2 above the minimum miscibility pressure, because then only maximum recovery can be attained. And once it is injected above the minimum miscibility pressure, it gels up with oil by first contact and multiple contact miscibility, whereby there is a mass transfer of CO2, mass transfer of intermediate to high component hydrocarbon into the CO2 solvent, and there is also condensation of CO2 into the oil phase, and as a result, only single phase exists in the reservoir. So the mechanism mainly is it swells, reduces viscosity, and helps the oil to flow to the wellbore. So we have, in Oil India Limited, we have identified a block in Naharkatia oil field. So this is a slight description of the block. The block has started production from 1967, and around 26 wells have been completed here. Currently, the block has a slightly higher recovery factor, slightly higher, more than 35% of recovery is there. So it peaked to an oil value of around 700 KLPD, and we have initiated water injection in this reservoir in 1982. As Gyani sir has already mentioned that Weezer analysis is very important prior to implementation of EUR. So water injection is still continued in this reservoir and injecting around 490 KLPD of water to 3 wells. So this is the workflow. In the Upper Assam Basin, we have around 300 reservoirs. So initially, we have carried out a screening study based on API gravity, viscosity, then reservoir thickness, permeability, and we have narrowed down to around 50 reservoirs. And from there, we have screened down to 13 reservoirs based on the availability of, size of the reservoirs, then the recovery factor, and the operational constraints which are associated in this part of the world. So those 13 reservoirs are then subjected to a detailed analysis of residual oil saturation, then the MMPs, then water flood management, and from that 13 we have narrowed down to 3 reservoirs which are suitable for CO2 EOR. And out of that 3, one reservoir needs better water flood management, and the other one is on the it is under water flood management and it requires some time to go ahead with CO2. But the current reservoir has been finally selected. This reservoir has a stock of around 14 million standard kiloliter of oil. So after that selection, the next phase is to carry out the lab studies. So the various lab studies, including SCAL and PVT studies, have been carried out, but here I am showing you the studies which are more relevant to CO2 EOR. The first one is minimum miscibility test. So this is the pressure at which maximum recovery is attained. As a rule of thumb, minimum miscibility pressure is defined in lab by injecting 1.2 pore volume of CO2, and the pressure at which around 90% of recovery is achieved is termed as the minimum miscibility pressure. So a slim tube experiment has been done for this reservoir. After that, core flood experiment in a 2-feet composite core has been carried out, which has shown us that an incremental recovery of around 26% can be achieved over and above the water flood case. So this is another test, that is swelling test, which is being performed to have an idea of the variation of formation volume factors and saturation pressure with additional injection of CO2. So all these data is a feedstock for the dynamic simulations to be carried out afterwards. So this is the modeling studies. The main objective of this modeling study was to identify the pattern, where the residual means the leftover saturations. Then we have to identify the injection volume and accordingly optimize the capex and also the incremental volume. So in the previous slide, if you have seen that the MMP was around 211 KSC for this reservoir, but currently this reservoir is under water injection and the pressure is around 180 KSC. So the thing is, we need some time to repressurize the reservoir to the minimum miscibility pressure level. That is why we have taken 5 years of time to attain that minimum miscibility pressure. And as you can see from the graph that the pattern has been identified in the southwestern part, where there are saturations left behind. So in the prediction study, we have selected continuous gas injection for 5 years, and after that water injection to be carried out. So the optimum rate is around 67 tons per day, which converts into around 25% of hydrocarbon pore volume in 5 years. And as a rule of thumb, 0 to 30% of hydrocarbon pore volume injection can be carried out with continuous injection and then water injection afterward. So incremental oil recovery of around 20.27 mmScale has been achieved in the simulation model, which accounts to an incremental oil recovery of around 11% within the pattern area. And within the reservoir, it accounts to around 2%. So the CO2 utilization ratio is, the average CO2 utilization ratio is around 6 MSCF per barrel within the pattern area. Now, with this study, we have initiated in fact, we have drilled the injector well, and it has been injecting water for last 6 months. So CO2 EOR economics. So even this is a pilot project, economics is very much important for any EOR project. So you can see we have carried out a sensitivity on various oil prices, and till around USD of $55, the NPV for the base case and CO2 EOR case are almost equal. Now the risk factors are there. Since we are operating in a matured field, our infrastructure is mature. We need a total revamp of the infrastructure for this particular reservoir. Then that is why the upfront cost is high. Then the main factor is the variable crude oil price. So at lower price, it is not economical. But another main factor is CO2 cost. In our calculations, we have taken a value of 2 USD per MSCF, which turns out to be around 45 USD per ton. So, which is on a lower side. So, concluding with, this is my conclusion slide. So, this project of CO2 EOR will establish the viability and feasibility of CO2 EOR in the northeastern part of the country, considering it to be one of the most, in fact, one of the highest seismically active area. Then we have our source, CO2 source in the form of Digboy Refinery and BCPL. In fact, the CO2 from BCPL is around 98% pure, which is favorable for the reservoir. So currently, CO2 is in news for climate control. So in our upstream oil and gas industry, CCUS can play an important role towards climate control. But the main issue is here the cost. In CO2 EOR, the cost involvement is very high, and that is why we require support from the policymakers so that the operators are encouraged to have, means obviously judiciously implement CO2 EOR in their fields, and also it will help the operators with small fields, because CO2 EOR can be implemented only when there is a high incremental oil, or we have a higher amount of STOIP. So with this, I come to an end to my presentation. Thank you for patient hearing.